The beginning of everything, the Big Bang, the idea that the universe was suddenly born and not infinite. Up to the mid-20th century, most scientists thought of the universe as infinite and ageless. Going back in time about 13.7 billion years ago, the Big Bang theory states that at one time the entire universe was confined into a dense, hot ball of energy. This is called a singularity. A violent expansion occurred, hurling this energy in all directions. Quarks then began to form new particles. The universe is now cold enough to allow most of the neutrons to decay into protons and form the first atom, hydrogen. Hydrogen atoms make clouds of gas known as nebulas. The atoms were pulled together due to the gravity and began to fuse together via the process of nuclear fusion. This process created our first stars in the universe. Evidence for the Big Bang. Redshift. All galaxies are moving away from one another from a central location. If an object is moving away from you, its energy is shifted to the red end of the spectrum. If an object is moving towards you, it is shifted to the blue end of the spectrum. This is known as the Doppler effect. Scientists theorized that if the Big Bang theory did occur, there would be background radiation left over from this event. This radiation was discovered, and it is in a pattern that reinforces the Big Bang. The Big Bang would produce large amounts of light elements. Heavier elements can only be created from supernovas, and therefore should be a smaller percentage of the universe. When we study the composition of the universe, we see that it indeed matches up with the predictions perfectly. All stars start off as stellar nebulas. As an average star ages, it turns into a red giant. Later, it becomes a planetary nebula, and lastly, a white dwarf. If the stellar nebula becomes a massive star, that star will become a red supergiant, and then after that, a supernova. At this point, the supernova will become either a black hole or a proton star. The electromagnetic spectrum is a range of all possible frequencies of the electromagnetic radiation. On one end of the spectrum, you have lower frequency waves, and on the other, you have higher frequencies. Radio waves are the lowest frequencies in the electromagnetic spectrum, and they are used for mainly communication. Radio waves are separated into 4 categories. Long waves, which are around 1 to 2 kilometers in wavelength. Medium waves, around 100 meters in wavelength, used by AM stations. VHF waves, this stands for very high frequency and has a wavelength of around 2 meters. This is where you find stereo FM radio stations. And lastly, UHF waves. This stands for ultra high frequency and has a wavelength of less than a meter. It is used by police radio communications, television transmissions, and military aircraft radios. Gamma rays are given off by stars and some radioactive substances. They are extremely high-frequency waves and carry large amounts of energy. They pass through most materials and are quite difficult to stop. You need lead or concrete in order to block them out. Because gamma rays can kill living cells, they are used to kill cancer cells without having to resort in difficult surgery. This is called radiotherapy. Gamma rays kill microbes and are used to sterilize food so that they will keep fresh for longer. This is known as irradiated food. And gamma rays are also used to sterilize medical equipment.